Howdy folks, John Braddock with Mountain Wave Weather, and the big talk of the town today is our severe weather event yesterday, or lack thereof. Interesting day we had setting up. A lot of the ingredients were there, but there were a couple subtle details, especially as we got a little bit later in the afternoon, that kind of tipped us toward this being more of a non-event than a major event. But anyway, I mean, it turned out how it turned out, and some people saw some heavy rain, some people saw a little bit of hail, but for the most part, people dodged the bullet yesterday when it comes to severe weather. So we're just going to talk very quickly about that today, and I'm going to offer a few of my thoughts, and let's dive into it. So we started off the day yesterday with a outlook from the Storm Prediction Center that basically placed a lot of the front range of Colorado in a slight risk category. Often depicted as yellow on the map, it's a 2 out of 5, so not a huge chance of severe weather, but it's something you just have to keep an eye out for. And the main threats they identified were hail and wind, and the possibility of heavy rain. The actual text output I had as part of my forecast was strong to severe thunderstorms possible along the front range, with primary threats of strong winds, sporadic large hail, and heavy rain. Models have been consistent about strong storm activity in and near the Palmer Divide region this afternoon. And there's a reason for that. When we started looking at models, we saw a pretty consistent pattern between all of them in terms of where they thought the biggest severe thunderstorms were going to be. And one of those areas was the Palmer Divide. So for example, this is the NAM3K model snapshot I posted yesterday morning, and it's for about 4 to 4:30 in the afternoon. You could see it has pretty much most of Douglas County and Elbert County in pretty heavy storms at this point. If we go to another model, for example, this is the HRRR model, the high-res rapid refresh. We see something similar on the setup where they have a big thunderstorm over Douglas County and parts of the foothills south of the Palmer Divide. And this one's a little bit earlier in the day. This one's about 3:30 in the afternoon. But you can definitely see the most consistent placement of these thunderstorms is right around or on the Palmer Divide. The last one we look at is the WRF model, or the Weather Research and Forecast model. This one is on a 2.5 kilometer resolution, which just means we get some finer details out of it. But as you can see, this is a very similar picture at about 4 o'clock in the afternoon yesterday. Much more widespread coverage of the thunderstorms than we ended up seeing, and much more widespread coverage with this model than the other two. So this is the one that kind of thought Denver would be in play, but if you remember, the other two didn't. So when you look at models for forecasting, you have to keep a couple things in mind. First of all, when you see such good agreement between a bunch of different models that are pretty accurate, that gives you more confidence in something that's going to happen. But you also have to remember they're not great at telling you exactly when or where things are going to happen. They can just give you a general idea. So in yesterday's instance, we looked at all the models homing in on the Palmer Divide, and that gave us more confidence that that area was going to see the weather. Unfortunately, we couldn't tell exactly where on the Palmer Divide. We just had an idea somewhere around our area, someone was going to see some big storms. Of course, there's more to it than just looking at models. Models are great for helping you build a forecast, but they're only one tiny piece. We look at a lot of other things as far as surface observations. We look at different things like CAPE. We look at what our dew points or humidities are doing, and in Colorado especially, we look at wind direction and intensity because, in the case of yesterday, that southeasterly wind was what was transporting a lot of that moisture and pushing it up against the mountains and the foothills. So there's a lot of small little moving pieces, but I'm not going to go into that a whole lot today just to keep this video brief because there's a lot of science and there's a lot of explanation behind it. But when we looked at the models and we looked at all the ingredients yesterday, there was a pretty good consensus that everything was there for it to be a pretty decent severe weather day. Again, not widespread, not everyone would see stuff, but if we got 3 or 4 or 5 big severe thunderstorms out of it across the Front Range up and down, we'd call that a pretty good forecast. But as is often the case with forecasting, you have to look at all these little pieces and you have to continue to evaluate them, because if you've got a day that just goes absolutely bonkers and there's storms everywhere, or you have a day that just completely busts like yesterday, there's usually a sign or a signal in the details there at some point that you have to capture. And if you miss that, that is what is going to, basically mess up your forecast. So here's a look at the main storm that we saw yesterday, and it was really the one that formed over southwestern Douglas County that took up a lot of the energy out of the atmosphere and made it very difficult for other storms to form. So we often see this with big severe thunderstorms. They pull a lot of the moisture and energy out. Other storms have trouble forming unless they have a little bit of help. This is the storm that eventually went down into Teller and El Paso County, became severe thunderstorm warned with some hail and some heavy rain, caused a little bit of flooding in and around the Springs area, and eventually died off. There was a couple other interesting features that I pointed out as well yesterday on my stream. And that was this. Basically caught this cool boundary on radar yesterday. And a boundary is an area of really intense lift that we get off of terrain or we get with winds crashing together. And in our case, we had southeasterly winds meeting northwesterly winds, and they just kind of crash and lift. They can't go down due to the ground, but they'll go up into the air. And that boundary serves as a thunderstorm formation zone. So it was cool to see it on radar. And in fact, that's where we got a lot of our pop-up thunderstorms yesterday, but they didn't survive very well once they moved off of that boundary. There's probably a good reason why for that. I looked at some other data in the form of these skew-T diagrams, and there's a lot of science behind these. I won't get too much into it, but they're very important in terms of weather forecasting and just understanding what's going on in the atmosphere. So, the red line's temperature, green line's dew point. You've got winds on the side, you've got lapse rates, you've got all this fun stuff you can look at, but it gives you a good idea of what's going on. What was interesting about yesterday is when we went back and looked at it, there was, pretty nice inversion in the morning, but there was also a little bit of inversion higher up in the atmosphere. So it almost, think of an inversion as a, cap on the atmosphere. If you've got one of those or two of those and you lift a parcel of air, it's going to have to break through those to form thunderstorms. Well, the first one we'd expect to erode in the day due to heating or terrain or stuff like that. The second one, you would need that extra push to get through, and that's where that boundary came in. Now, unfortunately, what happened is as you got later in the day, the winds kind of shifted to a south-southwesterly direction from what we saw, and that dried out the lower atmosphere. There was still a lot of lift upwards, but there wasn't a lot of moisture left, and part of that could have been contamination from other thunderstorms. But it was interesting to look at as the atmosphere kind of broke down yesterday. By the evening, we had a pretty good idea that it was not looking as good as it had, whether it was due to that one storm that went through or it was just due to the overall wind shifting. The last thing we'll look at here are the 24-hour storm reports from the Storm Prediction Center. So whenever there's severe weather that gets called into a National Weather Service office, it gets compiled in a report and sent to the Storm Prediction Center, and it's a good way for them to verify whether what they thought would happen actually happened. And in this case, it was pretty quiet in Colorado. You really only had the one report of hail near our area down near Colorado Springs, and then after that, that storm just kind of fell apart. There was an additional report of hail up on the northeastern corner of the state, and then, I think the place where the forecast verified the best was up northwards into Wyoming. I saw a lot of great shots of severe storm structure up there. There were quite a few hail reports, so that one panned out pretty well. But at the end of the day, this is the data that tells us whether our forecast was good or not. And it just didn't come together yesterday. It just did not perform the way we were expecting it to perform. So was yesterday a forecast bust from a severe weather potential? I'd say yes. The data's there, it supports it. One hail report in the Colorado Springs area, nothing anywhere else. That's a bust through and through. Unfortunately, it happens. We don't predict the weather 100%, but the ingredients were there yesterday. Everything looked good, but then the atmosphere threw us a curveball, and it happens. And it's okay to fail. It happens in weather forecasting, but someone like me who's passionate about learning weather forecasting, doing things like that, take each failure as a learning opportunity. I like to go back and look at everything, play by play it, if you will, and see what happened that was good, what happened that was bad, and then kind of try to apply those lessons to my future forecasts. And I think that's the only way we get better. So hopefully you enjoyed this look at it. We got some monsoon stuff finally starting to show this weekend that we're going to talk about here in the near future. But otherwise, if you missed out on the hail and you missed out on the storms yesterday, that's okay. That's okay. This is John Braddock with Mountain Wave Weather. Hopefully you enjoyed this. Take care, and we'll talk to you again soon.